All right, so let's talk about logarithms. Our boy Abe Lincoln was raised in a log cabin. It's nothing to do with what we're learning today. Just like to make connections though between history and math. All right, so you remember anything about logarithms? Where does it come from? What does it help us solve? So, yeah.
The inverse of an exponential.
Excellent. It's the inverse of an exponential. So like, if I was saying like, all right, 2 to the third power equals x, all right, I could just evaluate that. Like I know x is equal to 8. Wow, it was a weird 8. But let's say that I didn't know the input. Like I didn't know what we plugged in here. Let's say it was the other way around, like 2 to the what power equals 8. All right, well, in order to do that, if it wasn't a number that you could do in your head, you'd have to do the inverse. You have to switch your input and your output. And then this becomes the log base 2 of 8 equals x. And now x is equal to 3. So log helps us solve an equation when we don't know the value in the exponent, because a log is the inverse of an exponential, like this. So it allows us to switch the input and the output. And then we could type that into our calculator. So a lot of these logs you could do without a calculator. Some you can't. Now, when you're doing without a calculator, it's always good to set it equal to something and then put it into log form or put it back into exponential form. So like this is your base, this is your answer, that's your exponent. So in exponential form, it would be the base is 3, the exponent is x, and the answer is 27. So when you're doing the log of 27 base 3, or the log base 3 of 27, all you're trying to figure out is what number you raise the base to get what's inside the log. So what do you raise 3 to get to 27? So that would be 3. All right. So I'm going to give you a minute to try these right here. I'm going to pause the video and we'll go over them. All right. Any questions on these? I could go through them real quick, but basically like 2 to the 5th is 32. All right, with this one, it's going from a number greater than 1 to a number less than 1. So it means it should be negative. So like 10 to the negative first would be 1/10, but then you got to square that to make it 100. So if you square it, you get 1/100th. So the exponent that you raise 10 to get 1/100th would be -2. All right. One property of logs is that anytime you take the log of 1, it's always going to be 0 because the exponent, anything to the 0 power is always 1. So like 3 to the 0 is 1. And then this, I know I skipped this one, but this just said ln. That means natural log. It means the base is e. So same idea, like e to the what power is 1 was just 0. Because e is just a number. It's like pi. Pi is around 3.1. E is around 2.7. They're both mathematical constants that get used a lot and have letter representations, but they're just numbers. So that's just 0. And then here is 1, because anytime you take the log of something that's the same as the base, it's 1, because anything to the first power is Excel. All right. Now, common log and natural log, those are the two buttons that you'll see on your calculators. If you have an older calculator or like an iPhone calculator. On the TI Inspire, it allows you to change the base. But if you can't change the base, you can use a change of base formula. So the common log, that's just log base 10. And it's just written like log with no number. So if there's no number written and it says log, you can assume the base is 10. And if it says ln, which means natural log, or like lagunitas naturale in Latin, that's actually real. I actually made that up one time and I looked it up and that's basically what it stood for. It's like natural log in Latin, which is kind of funny because lagunitas is like a beer. But anyway, if you put the ln there, the base means e. All right. So we can change the way logarithms look by using properties. All right. So the change of base property. So this was huge back in 2007 when I was in high school and I had a TI 84. Hold it up for the world to see. Yeah, mine was even older than that, but still, that was around. Yeah. There's a nice one.
I have inspired my brother solar from home, so
That's a shame. We'll get it back. It's probably home now.
He came back, but I'm so used to this.
The calculator I could run.
Yeah. So if you look on that calculator, it just says
ln and log.
ln and log. All right. So it doesn't, if you needed to do the log base 2, you would have to use what's called the change of base formula. And the way I'll describe it is very simple. It's the log of the big number divided by the log of the small number. All right. And it doesn't matter what log you're using. So like this here, the log of 2 base 5, and I'll show you how to type it in your calculator different ways. If you didn't have log base 2 on your calculator, you could do log base 10 of 5 divided by log base 10 of 2. Or you could do the natural log of 5 over the natural log of 2. When you're changing the base, it doesn't matter which base of the log you're using, but as long as it's the same one and you do log of the big divided by log of the small, you'll get the same number each time. So take this one, for example. We want to do the log of base 2 of 5. Now, if you have a TI Inspire, you don't need to use the change of base formula. You should still know it for certain problems, but you could just do this directly.
I can also just use the math button.
It does let you edit the log?
It does like that.
Oh, that's cool.
Go to math, alpha, math again, and it just.
Oh, all right. So I guess the newer ones do it. That's great. Well, let's say that you're using like a scientific calculator, like this one right here. So like this one only has like natural log and log base 10. So you can also do the natural log of 5 divided by the natural log of 2, log of the big number divided by log of the small number. And notice how this will come out to be the same value. All right. And it doesn't matter which log you use. You can do base 10, log base 10 of 5 divided by log base 10 of 2. And see, same thing every time. All right, so that's the first property of logs that you should know. Even if you have a TI Inspire, you should know how to do that, to be able to rewrite logs with different bases. All right, so why don't you guys take a few moments to finish the bottom of the first page. So I'll do one more together. So like for this one, change of base property, the log of 9 base 6 could be like the natural log of 9 divided by the natural log of 6. All right, if I was generalizing this, I would say take the log of any base of the big number. What the hell? That was the weirdest, scariest sound ever. Is there like, are they like Ninja Turtles in our section? Wow. He's hungry. We gotta feed the sink. The sink's hungry. Take log of any base of the big number and divide by log of the same base of the smaller number. That's how I would generalize it. So take a minute, first try to compose yourself after that incident, and then just rewrite these two using the change of base formula.
How does this work? I just wrote log base as.
Yeah, that works.
Okay,
Are we gonna grab one?
Yeah. Only one way. I think the same. There you go. All right. Yeah, so for this one, you could do like log of 4 divided by log of 11. Here you could do log of 100 divided by log of 25. And you can make this like a different base too. You could do like the log base 7 of 100 divided by the log base 7 of 25. Any base you want, just gotta be the same one. Log of big divided by log of small. All right, we're gonna flip it over now. All right, so here's another property of logs. All right, so we know that the log of 50 base 10 is equal to 1.6989. Now, wow, it's crazy. If you rearrange those numbers, it's like my birthday, June 1st, 1989. It's missing a 1 though. That's crazy. But anyway.
Do you know tomorrow is McLovin's 40th birthday?
40th?
Yeah.
Damn, I'm feeling old.
I know, me too.
Wait, so that movie came out in like 2007?
No,
Oh, he was 25.
No, but he made the fake ID 25.
Right, because, you know, read a book like every, yeah.
Read a book from Muhammad.
Yeah, I was from Muhammad, but but what would you say about being 25? It's like everyone else.
I have a McLovin shirt. I'm working on my driver's test.
You
So
told-
yeah, so when I pass, I can even McLovin shirt.
That's great. Anyway, that's such a great movie. All right, so anyway, we're gonna learn another property of log. So it's how to break up a log of two numbers that you could factor to multiply to this number. So let's do an experiment. So log of 50, can we think of two numbers that multiply to 50? 5 and 10, bang. And then, what about another one? 2 and 25, nice. All right, so now we're gonna find the logs of those factors. So let's do that together on our calculators. So it's log base 10, so everyone should be able to do this pretty easily. Because if you have a log button on your calculator, it's log base 10. So let's find the log of 5, so log base 10 of 5 as a decimal. All right, and that comes out to be 0.69897. So we'll go 0.698. We'll just go 897. Plus here. All right, and then let's do the log of 10, which before I hit enter, can anyone tell me what this will equal? The log of 10 base 10? 1. Because 10 to the first power is 1. Nice. All right, so notice how the log of 5 is 0.69 and the log of 10 is 1. And both of these numbers multiply to 50. What do you notice about these two numbers and what that equals? Notice how these two add to that. So it looks like the log of 50 base 10 is equal to the log of 5 plus the log of 10. So let's see if that is just a coincidence or if it holds for these two. So now let's do the log of 2 base 10 and a log of 25 base 10 and see if these two numbers add up to 1.6989. All right, so let's do it. So the log of 2 base 10. All right, so notice what I did there in the TI Inspire. If you like arrow up and down, you can highlight something and then hit enter and it'll paste it and then you can edit it. You can hit second enter and it should do the last entry.
Wait, what?
Yeah. It'll work.
Yo, nice.
I know I'm talking about sometimes, Peter.
Woo!
I've grinded long times with those calculators. Done the work. All right, the log of 25 base 10. Not what I wanted. How embarrassing. It's always super obnoxious. Like, always gives me the exact answer.
Yeah.
Oh, the log of 25 base 10? You mean the log of 25 base 10? Is that what you meant? Oh, you mean 2 times the log of 5 base 10? Okay, that doesn't help.
2 to 5 by 10, you mean 1/5.
All right, so notice how that comes out to 1.397. All right, look, add this to that. It comes out to 1.6989. If you add this to that, it also comes out to 1.6989. And if we did the original log of 50 base 10, it's the same number. So we just discovered a property of logs. Give it up for yourselves. Nice job. Little mathematicians over here. All right, so on our table here, we see that, okay, the log of 10 plus the log of 5 is equal to the log of 50. The log of 2 plus the log of 25 is also equal to the log of 50. So what's the relationship between that and the factor 50? Well, what I just said, the log base 10 of 50 is equal to the log of 5 base 10 plus the log of 10 base 10. And that was also equal to the log of 2 base 10 plus the log of 25 base 10. So what operation needs to be done with the numbers in order to obtain this, all right, addition? So it's called expanding a log. You can expand a log of two numbers that multiply together using addition. So log of A times B is equal to the log of A plus the log of B. Pretty cool, right? That is cool, Stu.
Yeah, that's something to do.
It's true. All right, so let's try some of these together. So we have so notice how the base stays the same. So since that's a common log, these are also common logs.
So if I did ln for all of them, it would also work?
Yeah, so like
Okay.
it would have to start off as ln. So like the ln of AB would equal like,
Also ln of a and ln of.
yeah,
Okay, would that also be for any base, so log base 7?
Wow.
plus- Okay.
we're on the same page. I was writing log base 7 as you said log base 7, Peter. That's amazing.
That's a connection.
There's a connection there. Love the yeah, so it could be any base, the base has to be consistent. So like for the log of 6x base 5, that would just be the log of 6 base 5 plus the log of x base 5. Because 6 times x are like a and b here. So you expand it out as the log of one factor times the log of the other. Now, can anyone think of a way we could expand this even more? Log of 6 base 5 plus the log of x base 5?
Log of root of 3 base 5 and log of 2 base 5.
Yes, sir.
Or,
'Cause-
yes, sir.
Yeah, because this right here is 2 times 3. So you could break that up even more. You can make the log of 6 base 5 as the log of 2 base 5 plus the log of 3 base 5 plus the log of x base 5. Nice. So same thing with 7. Like you could break this up as, all right, the log of 12 base 7, 12x base 7 plus the log of yz base 7. So I broke it up as like 12x times yz. And then you could break this up as the log of 7, log of 12 base 7 plus the log of x base 7, and then break that up as the log of y base 7 plus the log of z base 7.
We're going to do log 2 base 7 times 2. And log base 7 times log 3 base 7.
Yeah, so you can break that up even more.
I just did times 2. 2 log base 7.
Yeah, so 2 log of 2 base 7
Yeah,
plus
2
log of 3. Nice. Excellent. And then it goes in the other way too. So if you have two log expressions that you're adding, you could condense it by multiplying the numbers inside the log. So like for A, you could condense this. You can make that the log of 6 times 2 base 5. So that's just the log of 12 base 5. I want to take a shot at B, what it would look like as one thing. So log base 2. So we're adding all three, which means you can condense it down and multiply all three of those things together. So you could do like 4 times 5 times x. So you get 20x. All right, same thing for this one. Notice how we keep the base the same the whole time? So it's still log base 6 of 8 times 3 times x times y. So 24xy.
Why are you multiplying like the number after the log?
The number inside the log? Yeah, that's just the property. So we discovered it up here. So we saw that, all right, the log of 50 was 1.69. So if you break up the log of 50 as the log of 5 times 10, that's going to equal the log of 5, which was 0.698, plus the log of 10, which was 1. So the property just says when you have the log of a product of two numbers, it's going to equal the log of one number plus the log of the other number. But the base doesn't change, so like what's inside the log. All right, yeah, no problem. It has also to do with properties of exponents, not to get on too much of a tangent, but like, notice how here, when we're expanding, we go from multiplying to addition. So we expand this into multiple logs by taking this two things being multiplied and add them. And when we're condensing, we go from addition to multiplying. So when we're condensing this to one thing, you multiply these numbers. Remember, logs are the inverses of exponentials. So when you have like, when you multiply, like, we'll say like x squared times x cubed, all right, this is multiplication, but now if I wanted to condense it to just x to 1 power, like what would I do? I would add these exponents. So with exponents, condensing goes from multiplying to addition. It's the opposite, addition to multiplication for logs, because they're inverses, and that's what inverse means. You just do everything in like the reverse order. So it's very closely related to the exponent rules, because they basically are exponent rules in reverse. All right, let's put our thing down, flip it and reverse it. All right, so now we got another property of logs. So let's look for quotients of 12. So two numbers that divide and give us 12.
66.
Then multiply.
Wait up. Divide.
Try.
Love the effort.
24 and 2.
20, 44, and 12. And what was yours?
24 and 2.
24 and 2. I like them both. 144 and 12. They divide to 12. 24 and 2. All right, so now let's do the log of these. Why do people keep asking me about kids returning to school and they're not even in my class? Do you have enough desks for? I don't have them in my class. How would I know? All right. Anyway. All right, log of 144. So it's base 10. So we're going to go log base 10, 144. We'll write these down. That comes out, let me guess, ready? Ready? 2.26. Ooh, close. Still got it. 2.158. All right, and then we'll do the log of 12. Oh, yeah, thanks, calculator. I appreciate you telling me that the log of 12 base 10 is a log of 12 base 10.
1.08.
It's 1.0. Okay, you're right. 1.08. 1.08. Gator's gonna 8. All right, let's do the log of 24. 1.38. Ooh, my old address, 138.
On the dot scale.
And then log of 10 base 2. That's gonna be like 0.3. If I'm already guessing, man. Oh, ooh. That was a guess, folks. 0.301. All right. Now, can anyone think of an operation that we can use with the quotients to get this number? So it's 1.0. Okay, thanks. You got it. It's subtraction. No, you're right. I'm gonna go to a movie that you've never seen, and I'm gonna shout out the ending right before.
Oh, you fool! I've seen both movies.
Well, there's movies that haven't come out yet, and I'll be watching you and the movies that you watch. Just kidding. No, I asked for participation. I got participation. I'm not complaining. All right. I love it. So it's subtraction. So if you look, like the log of 12 is also equal to the log of 144 minus the log of 12. If you subtract these two numbers, you'll get that 1.07 number. If you subtract these two numbers, you'll also get that number. Oh, what's that? You don't believe me? You don't believe me? Let's see.
Who guessed? Who?
Guess what? Believe me. You do that minus that. You get it? That minus that. All right, and then both of those are equal to the log base 12. All right, so just like with exponents, when you divide exponents, you subtract the exponents. When you divide two numbers with exponents, you subtract. So like if you took like x to the third over x squared, and we want to condense this to have one base, because right now it has two bases, you subtract their exponents. 3 minus 2 is 1. So condensing with exponentials goes from division to subtraction. With logs, expanding, when you expand this out, goes from division to subtraction. So like the log of A over B is equal to the log of A minus the log of B. So what's the relationship between the log of 12 base 10 and the quotient of 12? Subtraction. Oh, wait. So like log of 12 base 10 is equal to the log of 24 base 10 minus the log of 2 base 10. What operation needs to be done? Subtraction. All right. Okay, so expand. So now we have the log base 9 of 4/7. So you can expand that. Log of 4 base 9 minus the log of 7 base 9. I'll let you try B. For A on the condense, all right, you're subtracting the log of 10 and the log of 5. So you can write that as the log of 10 over 5 base 2, which would be the log of 2 base 2. And you can see how condensing can help you evaluate these without a calculator. Like the log of 10 base 2 minus the log of 5 base 2, that's hard to do on its own because I don't know the log of 10 base 2 or a log of 5 base 2. When you condense it down to log of 2 base 2, you get 1, which is because that's easier to evaluate. All right, so take a moment and try B, B, and C. All right, so any questions on B, B or C? So log of x over y base 10 is the log of x minus the log of y. The log of 6 base 4 minus the log of 12 base 4, you condense that to the log of 6/12 base 4, which reduces to the log of 1/2 base 4. And now this is something you could do without a calculator because I know the square root of 4 is 2. And since it's 1/2, we have to make the reciprocal, we have to find the reciprocal of 2. So we do that by making the exponent negative. So 4 to the negative 1/2 would be 1/2. And then this one here, the log of 8y, or the log of x over y base 6 is what that condenses to. All right. Okay. All right, let's skip this page for now. Skip this. We'll come back to it. We'll give you some practice another time. So let's go to number 4, the fourth property. All right, so we know. All right, so a log of 64 base 10 is equal to 1.862. So rewrite 64 as an exponential expression. So you don't really, so I know what it's saying here. So yeah, we do like 8 squared and yeah, 4 cubed. So you don't really need this part. I think I want you to put like the 2 there and the 3 there. So like you just, so we know which one's the base and which one's the exponent. We can keep it like that. So now we're gonna do the log of 8 base 10 is equal to something, and the log of 4 base 10 is equal to something. So we'll do that on our calculator. All right, so the log of 8 base 10, and then the log of 4 base 10. Now remember, we're trying to get the log of 64 base 10. Now, if you look at these numbers, you got 0.9, 0.6, and 1.8. So ignore the other digits because you could do this in your head. So like how many, do you see a relationship between like this number, the exponent of 2, and this number? Then you also have a relationship here where this is the log of 4 base 10, and to get the log of 64 base 10, we have to do 4 cubed. So the 3, if you look at this number and this number, 0.6 goes into 0.18 3 times. So the log of 64 is going to equal 2 times the log of 8 base 10, and also 3 times the log of 4 base 10. So when you have an exponent inside your log, you could bring it out in front as so this is equivalent to just having 8 squared. You could bring the exponent out in front and make it multiply. You get the same thing as that. Just like when you have power of a power with exponents, you can multiply them in any order, or you can multiply the exponents first. It's the same idea as the exponent property. So we'll jump right to this part here. So this came out to be 0.9. This came out to be 0.6. And then times 3 gave us, or times 2 gave us 1.8, which is what we were looking for. And this times 3 gave us 1.8. So the log of 64 base 10 was equal to 2 times the log of 8 base 10, and that was equal to 3 times the log of 4 base 10. So this here would equal b times the log of a. So if you have an exponent, you can just bring that right out in front. So let's finish up with just this bottom part of the page, and then I'll tell you what you could do for next time. All right, so for a, you can bring that 4 out in front and make it the log of x base 2. Here you have like a radical. Remember, a radical is the same thing as a 1/2 power. So you could treat that as an exponent and then bring the 1/2 out in front. So you get the log of y base 4. And the same thing works the other way. If you have like a scale factor out in front of a log, you could bring it as an exponent inside the log. So a log of x squared base 10. Same thing here, you can make that 1/2 an exponent. So it becomes the log of 9 base 10. All right, and these last two is just putting it all together. So with this last one, you could first expand it using subtraction. So it's like the log of 7x squared minus the log of 8y cubed, both base 4. And then you can expand this part by using addition. So like the log of 7 base 4 plus the log of x squared base 4. And then subtract this.
Why do you go log to the 10 power of 8 half power? You do log base 2 for B.
For B? Oh, it should be base 2, not base 10. My fault. Good catch. So plus log of y cubed base 4. Now notice how I put parentheses around here because we got to subtract this whole thing. So you really should subtract both of these. All right, then you could keep expanding it using the other property. So like this becomes a log of 7 base 4 plus 2 times the log of x base 4 minus 3 times the log of 2 base 4 because 8 is just 2 cubed. So you bring the 3 out in front. And then distribute the negative and get minus 3 times the log of y base 4. Okay. So I'll put this on Classroom, but here's what I want you to do. Just try these on so do these on page, whatever this is, page 3. And then do 1 through 6 on this page. And then next class, we'll do the delta math and finish this. All right, so the homework, and I'll write it on Classroom, is to finish this and do that 1 through 6 on this homework page. So finish the notes and then do up to 6 on the homework page. And then if you run out of time, you'll have time next class to work on it and then finish the homework. And then next class, we'll just have a delta math. So I'll be available all period to help you, but I'll keep the Zoom optional because we finished everything. So, but please join if you want to go through some of these or if you have any questions. All right.
My driver's test, oh God.
Good luck.